Okay, so for this one, we're going to eventually have to take the cube root of both sides, because we're after r, but r, as you'll see, is being cubed here. So we're going to have to undo that cube. But first, do you recall how to get rid of a fraction? So to get rid of a fraction, we're going to multiply by its reciprocal. So I'm going to start off with this. I'm going to write 4/3 pi r cubed equals v. I'm going to reverse the order. And then multiply both sides by the reciprocal of 4/3. That's 3/4. So that's going to make 1 over here. So everything there is going to go away, and I'm just going to have pi r cubed equals 3/4 of v. Now, 3/4 of v, you can rewrite that if you like. Another way to write that is 3v over 4. That's exactly identical. In physics, we might even write, where decimals come into play, we might even write 0.75 times v. All of those are the same. But for now, I'll leave it like you see it there. So now we're going to get rid of the pi, or divide by pi on both sides. You know what, this actually might be a situation where this is going to turn out to be better, because we're going to go r cubed, we divide both sides by pi, that's going to put a pi down here in the denominator, so with the 4. So we're actually going to end up with 3v, there in the numerator, and below is a 4 pi. And the last step is to take the cube root of both sides. So here's how we indicate cube root. We know that if we have, if it was m squared equals 11, we would take the square root of both sides to get that solved, cancel out the squared, and m would equal the square root of 11, whatever that is. We're going to do the same thing, but with a cube root. Now, new bit of notation here, you may or may not be familiar. If you see this symbol, and you don't see anything written in this location, then you can assume it's a square root. If it's a cube root, or a 4th root, or a 5th root, or a 100th root, if it's some root other than the 2 here, then we would write a little number here. So this, for example, means the cube root. If we don't see anything, what it really means is that there's a 2 there. Because the square root is so much more common, it's one of those things we don't write the 2 there. But if it's any other root other than a square root, you have to write a little 3 right in that spot there. So what we're going to do is we're going to take the cube root of both of the sides of that. Now the cube root is going to cancel. So the cube root is going to cancel the cubing here, and we're just going to end up with r over here on the left. That was the point. And there's nothing we can do with the right side. We're just going to leave it as the cube root of 3v over 4 pi. And that's all we can do. We're good. Alright, you may recognize this. Hopefully you do. This is the Pythagorean theorem. We're going to have to get very good at this. If you get to vectors, you'll see this shows up all the time. So in this case, we're solving for a. We're going to subtract. First thing we're going to do is subtract b squared from both sides. So I'm going to have, let's see, c squared equals a squared plus b squared. We're going to subtract b squared. I'll fix this. There we go. From both sides. So I have c squared minus b squared equals a squared. We're close. We don't want a squared, we want a. So we have to get rid of that square. So we have a squared equals c squared minus b squared, just writing it the other way. I can now take the square root of both sides. Which leaves me with a equals the square root of c squared minus b squared. And I pointed out in an earlier video, do not, under any circumstances, break that square root up over a minus or a plus. In other words, what is about to appear in this box is wrong. I just want to illustrate a common mistake, is that this is not a legal mathematical maneuver. Okay? No. No. Okay. I'm just going to leave it like you see it right there.